more JSON, way more JSON. JSON all the way. So, just for reference for me, who has heard of CouchDB to start with? Wow, awesome. Who has actually worked with CouchDB? A few? Has anyone run CouchDB in production? Ooh, yep, sweet, cool. So, CouchDB. I learned something today when I did the talk, the slides, that CouchDB is actually an acronym for Cluster of Unreliable Commodity Hardware. That makes a lot of sense to me. From the design, how CouchDB has been built, this makes sense. Hardware breaks all the time. CouchDB to the rescue. So, brief history. Where has CouchDB come from? In around 2005, a guy called Damien Katz, who used to work on IBM, big Lotus Notes setups. Anyone know Lotus Notes? It's a long time ago. Yeah, a few. Very interesting ideas around data storage. So he decided to take a gap year, sit down and write a new database. And that new database that decision kind of coincided with a language that's been around since the 80s, kind of emerging through a book written by Joe Armstrong around Erlang. Erlang, crazy language. Has anyone heard about Erlang? Few, yes. I'm an Elixir guy myself in the meantime, but back then I was an Erlang guy, just learning Erlang, found this database and thought, wow, there's a database written in this crazy language, I need to look into this. Around the same time, Jan Lehnhardt looked into this, and Jan was like, cool, how do I start working on this? I'm a PHP MySQL guy, I want to do another database, CouchDB sounds cool. And Damien said, not a problem, here's a book, learn Erlang. And Jan was, okay, let's learn Erlang. And then became sort of the co-contributor to the database. And there was a small group of about 5, 6, 7 active developers writing CouchDB back then. So this goes into sort of early 2007, 2008, when they incubated the database with Apache. It became a first-level Apache project. Then the big, 2006 for reference, the Google paper came out for BigQuery that sort of started the entire NoSQL craze. And so the hype droves went through the CouchDB community and then kind of exited towards MongoDB at some stage and sort of left behind a really, really robust database engine. But the hype cycle went on, which created Couchbase, which was a merger between Memcache, I think it was called initially. Memcache was an in-memory database. It was merged together with CouchDB. And they created a startup to get funding, and it went very pear-shaped from there. Another development that started around that time was PouchDB, so anything on the client that has the same replication protocol, offline first. Cloudant emerged, which is like a company that did CouchDB consulting and built a thing called BigCouch, then sold out to IBM, so we go full circle IBM again. They contributed back to CouchDB, and now in CouchDB we have not only a good replication mechanism, but also a cool clustering mechanism that came out of the merger from Cloudant into IBM back to CouchDB. Anyway, so CouchDB has been around for a long time, 2005 till today. Still in active development. Lots of people came and left, but there's a really, really active core. I ran a thing called NoSQL somewhere in 2000, I don't know, 9, 10, something like that in Wellington, where we talked about all the papers that came out in that time about like crazy NoSQL stuff. And around that time, everyone sort of started to talk around data stores in JSON and document-based data stores and so on. I thought it's a new thing. It was not. But it was the next sort of wave of NoSQL databases that had that name, captured that name, and sort of built on that. So with that as a backdrop, we're talking late 2000s, early 2010s. NoSQL is in full swing. I want to talk briefly about what CouchDB really is, for those that have never heard about it or never seen it. So CouchDB, on a very basic level, is a JSON data store. It's a key value store. You give it a key. You give it as a value a JSON blob. And you can store arbitrary JSON data in it. The only requirements you have is it has to have an ID. So underscore ID field is the same as the key here. This is the key. This is the value. The value is that data blob. The ID is the name of the document. And it's got a revision. And the revision is important. We'll get to that. But if you want to identify an object, a document within CouchDB, you always need to know the revision, because the revision is important for updates. So you're not updating a document that had been updated in the meantime. So a pretty cool thing. We'll get there when we talk about replication. And the rest is freeform, like any JSON data. Thanks to Hugo for explaining JSON before. Like any data you want to have in there, you just plop it in there. And it's there for you to play around with. So how do you play around with it? If you've got a blob of data in a data store, you normally want to query it. So how do you get that thing out again? In CouchDB's case, they've decided to not go down the SQL or SQL-ish layer. They decided to write a MapReduce interface, which is slightly different to what we normally use when we query a database. MapReduce interface in this case looks like that we have design documents that define views, and the views define maps and reduces. And everything is written in JavaScript normally. However, you can write maps and reduces in whatever language you fancy, as long as you implement your own query server or you use Erlang. Both of these are not always straightforward. I love Erlang. Most people don't. So this is what a view document looks like, or a design document, sorry. Design document is really just another key value thing. You've got a key, which is design, and a name, so underscore design for the namespace, and then a name. And then you've got a revision again, and you've got a blob of JSON. This time the blob of JSON has a bit of structure to it. This views key defines for this design document that we're talking about a view in CouchDB terms. Then you give it a name, and then you give it a map function. And a map function is just, as you see, a string of JavaScript. And that string of JavaScript can be as complicated as it can be, or as simple as you want it to. The only real requirement for a mapping function is that it has an emit that emits something. In this case, we emit an event and a number. It has also an optional reduce function. And a reduce function in this case is a built-in function sum. So how this, and we've got a language qualifier. The language qualifier is standard JavaScript. If you omit this, it, I think, defaults to JavaScript. But you can put in Erlang or whatever your view server is that you decide to write. There are a few alternative view servers that exist for other languages. I haven't played with any of them. I tried the Erlang one for a while. It just makes it harder for people to collaborate with you. So how does it look like when you call a view? In this case, we call the view with the parameter reduce false. So we're actually interested in the map that we are getting back. So the map, if you call this, returns a total of 2 rows. And then we've got 2 IDs. With 2 keys and a value of 1, because this is what we designed back here. We said if we have a doc type of person and a doc has an attends thing, and we have a for each in that attends list, if we go back to actually, we have this person that attends events. We've got a map function that looks for these events and then maps out GeekSessions. And if it has GeekSessions in it, it emits 1. And now we see that both Sergio and I go to GeekSessions. So this is a map. Often you're interested in the map data. Sometimes you're interested in the reduce data. So you've got a parameter that you can pass it, reduce, false, or true. If true is optional, if you go the full reduce, you get a value of 2. Because there were 2 of us. It's way more here. Didn't have everyone in the database. So, cool. Does the concept of maps and reduces and documents kind of make sense? Cool, let's go one further. We've got a pretty cool thing. It's a replication protocol. And the replication protocol builds on top of the changes feed. Changes feed is a crazy cool idea. Exists in many databases, but I think CouchDB has put it onto a level that makes it just so easy to interact with. It's beautiful. So the changes feed gives you a complete overview of every change in the database. I have one here, yeah. So if you go and call _changes, you get results, a sequence, and an ID for a document, and a revision for a document. And with that's all the information you need in order to get the change that was made at this point. That is for the entire database. But you can write filters on top of that and filter out changes with specific properties. So imagine you've got, say, a job queue. You drop all sort of types of jobs into the job queue, and then you've got workers that take jobs out of the job queue depending on what type of job you dropped in. You can do that just with the changes feed. You listen for the changes, you drop in documents, they drop out at the end with the changes feed with those properties that you're interested in, and you've got yourself a simple job queue. So changes feed is amazingly powerful, really, really cool stuff. The most sort of generic version of that is a replication protocol. And the replication protocol is, again, a document that lives under replicator. All you give it is a source and a target, and you tell it if it should continuously replicate or if it is a one-off. So changes feed, replication protocol on top of the changes feed sees everything that's happening in the database. To create a replication, you literally just create another document. Or you can even just do it with a post request. So the post request will generate that document for you if you want to. But if you want to do it explicitly, you can just insert a document into the replicator namespace, and boom, you've got a replication setup. It can do both push and pull. So depending on your network topology, you either go to the replica and say, give me all the changes, or you go to the server and say, give that database over there all the changes. So pull or push, depending on where you are. This is probably the easiest I've ever seen a database configure replication. Has anyone configured replication for databases? Was it fun? This enables you to do crazy stuff. We get there. One of the crazy things that I used replication for is when you're in development and you've got a production problem that you're trying to replicate on your local machine. Sometimes these problems are not possible to replicate without production data. Now, creating a data source that replicates the production data that triggers exactly that bug can be a job in itself. Or you just take the relevant part of the database, replicate it locally, trigger the bug, fix the bug, and push it to production. And that way, you've got a full set of production data. Don't do that with your customer data. But, but with other data, like job queues are a classic one. Pull that in, and you can replicate the bug locally. Saved my butt a few times. So now we've got documents, we've got views, we've got a MapReduce, we've got replication sitting on top of it. And then we've got another really, really cool feature, and it's a really nice UI. So the current version of the UI is called Photon, which is the false Photon. Photon was the old one. Play on whims. Anyway, it's a bit tiny. Okay, so this is how it looks like. You get a full UI to manage your database out of the box. It's got permissions built in, so you can give users limited access to certain parts of your server or your data. It's got replication in it. It's got database server administration in it, and it's got obviously a UI in order to create views, and it's got a UI in order to write your documents. So I used that in the past as a really, really super basic CMS before I had enough bandwidth to write a proper one. I gave the content guys in our company like, this is the structure of a JSON blob, and in there is like the blob of text that you need to write. Do that, and don't mess with the rest. And it kind of worked most of the times. So you get tools out of the box for free that kind of help you to bootstrap and get off and going. Cool. So, cool database. Why should you bother? It's like, who the hell uses it? So this happened 2008. That was me sitting in Wellington in New Zealand, writing a domain name registrar of all things. And I wrote it with a framework that had very good support for PostgreSQL, which I used. And it had absolutely no support for CouchDB, which I thought is sad and wrote. And so I wrote the CouchDB driver for Perl, which was the language that we used back then. Yes, I'm old, I know. And wrote an interface for all the data that's kind of hard, like configuration data and content, where you don't really know where it shows up on the site. So you kind of have this messy thing where you have your tables that have like key value thing, and then it's always messy to model in SQL. So we just threw all of that into CouchDB, and all the stuff that we know is very well done in relational databases like user management and shopping carts and all that stuff lived in Postgres. Yeah. And then we ran for about 2 years, and more stuff went into CouchDB, and we sort of hit that point where we thought, why do we have two databases? So either go this way or that way. And we decided to go Couch. That was interesting. Writing a shopping cart in CouchDB is not obvious. But when you realize that a sum of all the line items is just a reduce function, it's actually pretty straightforward. It just takes you a moment to rethink your assumptions that you have in terms of data modeling that you learn from a relational sort of point of view. The core side effect of that is it's blazingly fast, because a view is compiled at view insert. So the compiled view creates all the indexes it needs in order to run that view at insert. So writes, very expensive. Reads, blazingly fast. Pretty much all data you need on a web platform, very, very read heavy, not very write heavy. So perfect fit for the workload. So we wrote this thing and thought, let's see how far we can push it. We pushed it that far that we sold the company in 2019. They're still running on CouchDB. I don't know if they know, but I don't care. They bought it. They didn't understand what they buy. It's okay. The other cool side effect of that was all the CouchDB guys had their domains with us from pretty much day one when we went online. So I know Jan very well. I know all the people that ran Couchbase for a while because they obviously had their domains with us before they got like big and had to use commercial registrars that are way bigger than us. But that was a really cool insight into what's happening in CouchDB. And I got mails not only once from Jan or someone else on the team. It was like, do not talk about the domains that we are just registering. None of that is like we have penalties if we talk about this stuff. So it was pretty cool. So that is sort of the technical side of it, so the development side of it. There's a pretty important other part of this, that's the ops side. So how do you run CouchDB in production? Is it easy to maintain? Is it easy to run? What does it mean from an operational point of view? And it's crazy cool. Another really cool feature of CouchDB is they decided super early on that they want to have a file format that is append only. So every change, every new version of a document you write to the end of the database file. There is a reorganization step that you can trigger manually. I think in the meantime there is a way to do that automatically. I would not recommend. Do this, do it manually at very clear moments where you know everything is safe. The cool thing about the append-only file system is, for example, your page awakes you at 3 o'clock in the morning, server is burning, you ran out of disk space or something else stupid, and you need to move everything to a new server. With CouchDB, you literally grab the blob of data, push it onto a new server, start the server, and it just starts. There is no corrupted files, there is no import, export, whatever, restoring from backups, nothing. You just like literally file, daemon, start, go, runs. If you've got a replica somewhere, you replicate in the last few changes that it lost while the disk was burning, and that's it. It just goes. It might spend a moment or two on recompiling views, but even that you can kind of get through if the databases are not too big. So there are maybe some small niggles, but compared to like restoring a broken Postgres at 3 o'clock in the morning, I'll take a CouchDB every day. So when our servers exploded or burned or whatever, the database was never a concern for me. That was just given, it was just running. So big upside. The other thing is replication just works. So if you want to back up your database, you just set up another server. You replicate to it, it's a hot standby or a hot product, like not a standby, but actually a production machine. As we used it, we had a cluster. Every cluster had 2 identical machines. You have HA proxy on one side, HA proxy on the other side, and it just looks at its own database and the other one in case its primary database is down. So even if you do upgrades, you don't even need to think about like taking down a database or anything. It just HA proxy does it for you. So replication is easy, backups are easy, and anything that's sort of ops related, it's always a hassle with databases, just like doesn't really exist. Oh yeah, talk to that a bit. So local data replicates everything down to your local machine, work on it, or even we use it for content creation. Like our content guy had a working version of the website in a VM on his local machine, had a button that we built for him to replicate the content database down, could work locally on blog contents or site content or whatever, hit a button again to replicate everything back up, and the site was live. So these things, these ways of working with your site is a completely different way than if you have like a CMS that's online. We've got staging environments and things like that. It's just like where you need to move through different stages. Whereas if you have it in such dynamic way, you can make changes and react to customer needs really quickly. A fast-growing startup where you don't really know your customers yet really well, and where you focus changes like 10 times a day because you get new data and new insights. This is a really cool way of building content really quickly, building a relevant site really quickly. Fast pace of iteration. Cool. So, downsides. Obviously, there are. MapReduce. I think most have probably seen that comic. So MapReduce means you think about your data in a completely different way. And you don't need to write your map functions in Erlang, but you normally write them in JavaScript. But it is a thing that hit us a few times where others on the team wanted to do data mining and drill into the data, which is really hard to do if you don't know the data very well. And you always need to do it with a MapReduce paradigm. So this is cumbersome to the point that the community went like, okay, we have to fix this, and wrote Mango, which is a query engine that does ad hoc queries really well. So Mango is, again, just JSON. We're talking about JSON today. It's got a selector syntax, and it's got a field syntax. So you kind of, so this is the most basic example. You want to select based on, in this case, a type field that is equal to event. And then you want to return the field's ID and name. So this is, again, this interaction with data, but now with an ad hoc interface. And then if you fire that against the database, you get ID and name back. So similar pattern, you always get a list of documents, you always get some IDs, you always get some content. The cool thing here is you also get a bookmark back. So if you have a limit query in there, for example, I only want to have the first 10, you can use this bookmark to go give me the next 10, and it knows internally like where it needs to set up again, where that 10 ended or currently ends based on all the changes in the database. So this is a pretty cool feature. So even the ad hoc queries are now not really an issue anymore. And I think that leaves it as a really cool alternative to the more traditional stack. I don't recommend anyone to go, I'm writing this new crazy thing, I'll go CouchDB all in. Go in doses if you never worked with an NoSQL database. It will break your head in ways you haven't imagined, but once you actually are in there and really understand how a NoSQL database works, CouchDB or any of the other ones, you start to think about data in a completely different way, and it enables you to do things that you think are impossible. So if you want to play with it, and I highly recommend playing with it, couchdb.apache.org has you covered with documentation, with binaries for all the usual platforms. It's packaged for everything. It's been around since 2005. It's everywhere. Like if you need CouchDB for your architecture, it's there. Runs from Raspberry Pi all the way up to servers. There is PouchDB, which is really, really cool for offline first things. If you do mobile apps that need to synchronize to a central server, PouchDB is amazing, same replication protocol, just a very thin, small JavaScript library that you can bundle into your app and then replicate up to servers. So this is worth playing with. Cool. Have fun and play. I'm Lenz, Nobus09 pretty much everywhere.